On the 4th of July, this storm was almost nothing. A loose knot of thunderstorms drifting over the western Pacific. The kind of blob a satellite can barely draw a circle around. The kind of thing forecasters watch for a day before deciding whether it even deserves a name. Less than 24 hours later, it had a name, it had a shape, and it was already tearing across the seaboard of the northern Philippines as Tropical Storm Maysak. And here is the number that reframes everything you are about to hear. Maysak was the 5th named storm to strike this same soaked country in roughly 3 weeks. 5. In 3 weeks. On ground that had not even had the chance to dry between the blows. That is the part that turns a middling storm into something far more dangerous than its wind speed suggests. Because when Maysak's rain bands swept across Luzon, they were not falling on dry earth that could soak them up.
They were falling on hillsides already sliding, rivers already high, reservoirs already spilling over the top, on neighborhoods where the water from the last system had barely finished draining out of people's living rooms. This is a storm landing on a wound that never closed. If you want to understand storms like this, the way the people who track them for a living do, before the headlines catch up and long after they scroll past, subscribe and hit the like button. This channel follows these systems as they unfold, in real time, with the real numbers. It genuinely helps more than you'd think. So let me tell you exactly where things stand as I record this on the 5th of July, and why the professionals watching Maysak have their eyes locked on something other than the wind. Maysak has already done its worst to the northern Philippines and moved on. It crossed the seaboard and the mountainous spine of Luzon as a tropical storm, then pushed out over the water and drove west, straight for southern China. Over the weekend, it made landfall on Hainan Island, China's tropical southern province, the first tropical cyclone to reach the Chinese mainland in all of 2026. Then it kept going, crossing the water again and coming ashore a second time on Saturday night, right along the coast, near the border between the Guangxi region and northern Vietnam. And notice what the numbers are doing. When it hit Vietnam's Quang Ninh province, the winds near the center were around 101 kilometers an hour, a bit over 60 miles an hour. Strong enough to snap trees and peel metal roofs off buildings, but not a monster wind, not a screaming super typhoon. By the time it dragged itself deep inland, it had weakened further, down to a tropical depression, and the meteorological agencies started lifting their storm wind warnings. Because as Maysak weakened, the warnings did not stop. They intensified. Listen to what the meteorologists were actually saying as the wind died down. Now a slower-moving tropical storm, they said. Maysak no longer had the punishing winds that lashed Vietnam and Hainan. But as it heads inland and weakens, it will dump the water it sucked up on its way across the South China Sea, triggering catastrophic flooding. Catastrophic. That is not a word forecasters reach for casually. And notice what triggered it. Not a strengthening storm, a dying one. That is the thing I need you to hold on to, because it runs against every instinct you have about how storms work. The wind speed dropping is supposed to be the good news. Here, it was the setup. Think of it like a sponge. A tropical storm spends days crossing warm ocean, and the whole time it is soaking up water, pulling moisture off the sea surface and packing it into its clouds, hour after hour. A fast storm carries that sponge across a coastline and out the other side before it can wring it all out. But a slow storm, a storm that stalls and grinds inland at a walking pace, sits over one region and squeezes the entire sponge onto it. Same water, concentrated into a fraction of the area. That is Maysak. And so the story splits into two. There is the wind, which has already faded into history. And there is the water, which, as I speak,
is still climbing. Let me give you the names the country never wanted to say again, because to understand why a merely moderate storm is landing like a knockout blow, you have to understand what was already on the ground before Maysak ever showed up. For weeks before this storm even had a name, the Philippines had been drowning. The southwest monsoon, the seasonal flow of wet air that soaks Southeast Asia every summer, had been running hot and heavy. Its rains enhanced and dragged inland by a string of tropical systems marching through one after another. Think of the monsoon as a fire hose that runs all season long, and each passing storm as a hand that grabs that hose and aims it directly at the same doorway. By the time Maysak arrived, that doorway had already taken storm after storm after storm. The fifth in 3 weeks. The ground was not soil anymore in many places. It was mud with no more room to hold water, hillsides balanced on the edge of failure, rivers running bank full with nowhere left to put the next downpour. That is why the wind number lies about a storm like this. On paper, a 60-mile-an-hour tropical storm sounds survivable. It sounds like something you close the shutters for and ride out. But drop that same storm onto saturated ground in a country that has been pounded for 3 straight weeks, and the arithmetic changes completely. You are not adding a storm to dry land. You are adding water to a glass that is already full to the rim. Every drop from here spills over the edge, and the edge is where people live. That is the sentence I want you to sit with for a second. Every drop from here spills over the edge. Because in the northern Philippines, in Luzon and its mountain provinces, the edge is a hillside above a village, or a riverbank below a town, or the low ground of a city built on a floodplain. And this is the pattern that makes these back-to-back storms so lethal. It is rarely the strongest single storm that produces the worst disaster. It is the one that arrives when the land has no defenses left. The famous killers in this part of the world were often not the highest wind speeds. They were the storms whose rain fell on ground that could not take one more drop and turned mountainsides into moving rivers of mud in the space of an afternoon. Even before Maysak came ashore, the toll was already being written across the region. Deaths, evacuations, people relocated from cages and rafts on the water and from homes on the low ground. Thousands of them moved out ahead of a storm that, on paper, barely qualified as dangerous. In China's south, in Vietnam's border towns, in the Philippines that took the first blow, the numbers of displaced were climbing before the worst of the rain had even fallen. That is the signature of a storm landing on an exhausted landscape. The response has to begin before the event, because everyone already knows the ground has nothing left to give. And here is a detail that tells you how the professionals are thinking. Watch which warnings they kept up and which they let drop. As Maysak faded to a depression and the wind alerts came down, the agencies deliberately held their heavy rain warnings in place. The orange tier rainstorm signal, the alerts for flash floods and landslides. They took their eyes off the sky and put them on the ground, on the rivers, on the reservoirs. Because they knew the wind was never going to be the thing that killed anyone here. When a warning system keeps escalating while the storm weakens, it is telling you something you cannot ignore. It is telling you the danger was never really about the storm at all. It was about the water the storm brings, and the ground it brings it to. So keep that split in your mind. The wind that has already gone quiet, and the water that is still rising. Because that water is now pointed at 2 very different places, and it has already started drowning both. On the northern Philippines, on ground softened by a month of rain, and on southern China, where nearly 9 million people in a single city just watched their emergency response jump to its highest possible level.
and where the first reservoirs have already begun to fail. Those are the people standing in the water right now, and I want to show you exactly who they are, and why, for so many of them, there is nowhere higher left to go. Let me tell you exactly who they are, because the map of Maysak's damage is not a wind map, it is a water map, and the water follows the shape of the land. Start in the north of Luzon, in the Cordillera, the great mountain heart of the northern Philippines, a tangle of steep ridges and deep river valleys with towns clinging to the slopes. This is the roof of the country. Baguio City sits up here, more than a mile above the sea, a hill station built into the mountainsides where people go to escape the tropical heat. And it is precisely because it sits so high, so steep, that it is one of the most dangerous places in the country when the rain comes. Water does not sit on a 30-degree slope. It runs. Everything the sky drops onto those ridges gathers speed and pours downhill, funneling into the valleys below, where the towns and the farms and the roads are. Below the mountains, the land flattens out into the central Luzon plain, the great rice bowl of the country, a wide, low tabletop of paddy fields laced with rivers. The Pampanga River drains a huge share of that plain, and the Agno River drains the western side. When the Cordillera dumps its water, that water has to go somewhere, and where it goes is down onto this flat, low ground, where it spreads out and stays. A mountain sheds water fast. A plain holds it. So the people at the bottom of the system are drowning in rain that fell on mountains they cannot even see. And this was all happening before Maysak. The reporting out of the region described the same grim inventory that comes with every one of these events. Neighborhoods already underwater, families already pulled out of homes on the low ground, roads already cut, communities already relying on rescue boats to move through streets that used to carry cars. The land was already at capacity. Maysak was the storm that arrived at a house where every room was already flooded and simply raised the level in all of them at once. Now here is a piece of geography that catches people off guard every single time. Manila, the capital, floods before the storm even arrives. Not during, before. And once you understand why, you understand the whole vulnerability of the place. Manila sits on a low, flat coastal delta, wedged between the sea on one side, Manila Bay, and a vast lake, Laguna de Bay, on the other. Much of the metropolis is barely above sea level, and parts of it are sinking as groundwater gets pumped out from underneath. Picture the whole city as a shallow dinner plate set down between two full bowls of water. When it rains hard, the water in the plate has to drain out, but it can only drain if the bowls around it are lower than the plate. During the monsoon, they are not. The bay is up, the lake is up, the rivers feeding through the city are up. So the water has nowhere to flow to. It just pools in the plate, in the low districts, and rises. That is why you get flooding in Manila from rain alone, days before a storm's eye is anywhere near it. The storm does not have to arrive. It just has to reach out with its outer rain bands and its enhanced monsoon flow, and add water to a plate that is already brimming. And the low-lying districts along the rivers and the bay, the crowded, dense neighborhoods where the least room for error exists, are the first to go under. Upstream of all this sit the reservoirs, and they are the quiet, moving part of this whole story. In a normal year, the big dams that ring Luzon, the ones that supply Manila's water and generate its power, are gates that hold water back. In a monsoon like this one, with storm after storm feeding them, they fill to the brim, and then the operators face an impossible choice. If they hold the water, the dam risks overtopping or failing, which would send an uncontrolled wall of water downstream. So instead, they open the gates in a controlled release, letting water out on purpose, into rivers that are already full, toward towns
that are already flooding. It is the least bad option in a situation with no good ones. But for the people living below those dams, it means the flood arrives twice, once from the sky and once from the reservoir upstream that had no more room to hold the rest. Think of it like a bathtub, with the tap running full blast and the drain half clogged. You can let the tub overflow slowly and mop as you go, or you can bail buckets out over the edge onto the floor. Either way, the floor gets wet. The dam operators are bailing buckets, and the floor is where families live. So that is the first target, still soaking as I speak. Now cross the water to the second one, where the scale of exposure is on an entirely different order. Maysak came ashore on Hainan Island first, China's tropical southern province, a place people think of as a resort, a warm water vacation island with beaches and palm trees.
But it is also home to around 10 million people, and it sits directly in the path of storms crossing the South China Sea. When Maysak approached, Hainan did what island provinces have to do. It shut itself down. Authorities suspended trains, closed schools and workplaces, and the whole rhythm of the island ground to a halt to get people off the roads and into shelter. And that shutdown catches the one group that always gets caught on a tropical island: the tourists. When Hainan closes its transport, when flights and ferries stop, the visitors who came for the beach are simply stuck. There is no driving inland to escape, because the whole point of an island is that there is no inland. There is no interior to retreat to. You are on a piece of land in the middle of a storm's path, and when the doors close, they close with everyone inside. But Hainan was only the first landfall. The real mass of people lies on the mainland coast, and this is where the numbers become almost hard to hold in your head. Maysak's track carried it across the water and into the coastline of southern China, into the Guangxi region, and up against the border with Vietnam, one of the most densely populated coastal stretches on Earth. A nearly continuous ribbon of port cities, industrial zones, and river deltas, where tens of millions of people live within reach of the sea. And here is the figure that tells you how seriously China took this dying storm. Nanning, the capital of Guangxi, a city of close to 9 million people, went to its top-level emergency response as Maysak's rain moved inland. The top level. Not for a screaming super typhoon with 150-mile-an-hour wind. For a weakening tropical storm whose winds had already collapsed. That is the tell. When a city of 9 million throws its highest alarm at a storm that has technically fallen apart, it is because the officials there know exactly what I have been telling you, that the wind was never the threat. The water was. And the water made its case almost immediately. Even before the worst of the inland rain, Maysak had already triggered a reservoir breach in the region. A reservoir failing is the single fastest way rain turns into catastrophe, because it takes water that was gathered slowly over hours and releases it all at once, downstream, in a surge. The evacuations across the south were already in motion. People moved out of low ground and off the coast ahead of the flooding. The same defensive crouch you saw in the Philippines, for the same reason. Everyone already knew the ground and the rivers had nothing left to give. So now you have the two targets clearly, and you have the same paradox in both of them. In both places, the wind was survivable. In both places, the officials escalated their warnings as the wind died. To understand why, I have to take you inside the physics, inside the reason the wind speed lies about a storm like this. Imagine two garden sprinklers, both throwing the same amount of water. One you walk quickly across your lawn, the other you set down in one spot,
and leave. The fast one leaves the whole lawn barely damp. The slow one carves a puddle, then a pond, then a small lake in the exact place it sat. The total water is the same. The concentration is not. A screaming super typhoon that races across a coastline at 25 miles an hour dumps its rain across a wide swath and moves on. A limping tropical storm that crawls inland at a walking pace sets the sprinkler down and leaves it running over one region for a day, 2 days, 3. Same water, a tiny fraction of the ground. That is why the death tolls in this part of the world so often belong to the slow, sloppy, weakening storms, and not to the record-setting winds. Now add the mechanism that actually makes the rain. Inside a tropical storm, warm, wet air is constantly rising. As that air lifts, it cools, and cooling wet air cannot hold its moisture, so the water condenses out and falls as rain. This is the same thing that happens on a cold glass of water on a summer day, when beads form on the outside. The storm is a machine that does this on a colossal scale, over and over, as long as it has warm, moist air to feed on. A slow storm keeps that machine running over the same valley for far longer. Every hour it lingers is another hour of that conveyor lifting wet air and squeezing it out onto the ground below. And Maysak had one more thing feeding it, the enhanced southwest monsoon. This is the part that turns a moderate storm into a rain disaster, and the geometry of it is worth seeing clearly. The monsoon is a steady flow of very wet air streaming up from the warm seas to the southwest. On its own, it rains, but when a tropical storm parks itself near that flow, the storm's own circulation grabs the monsoon and bends it, aiming that fire hose of moisture directly into itself and into whatever coastline it favors. The two systems add together. The storm does not just carry its own water anymore. It becomes a pump, dragging the endless wet air of the monsoon into one place and wringing it out. That is why the rain totals from a storm like this can dwarf what the storm alone should produce. Now do the arithmetic, because the arithmetic is where the danger lives.
Suppose a mountain slope in the Cordillera takes something on the order of 1.5 feet of rain over a day and a half. A plausible figure for this kind of monsoon-charged system. Ask a simple question. Where does that water go? On a steep slope, it cannot soak in, because the ground is already saturated from 3 weeks of rain. The sponge is full, and a full sponge sheds water instead of absorbing it. So it runs. Downhill, fast, gathering into streams that gather into rivers, all of it converging on the flat, low ground below where the towns sit. The mountains do not hold the water. They deliver it, express, to exactly the places least able to escape it. And here is the part that should stay with you. This process does not stop when the rain stops. It keeps going for days. The water that fell high in the mountains is still working its way down through the river system long after the sky clears. The rivers keep rising after the storm has gone. The ground keeps giving way after the last drop has fallen. So the calendar of danger runs behind the calendar of the storm. And the most lethal hours of an event like this often arrive on a clear, calm morning, when people look up at a blue sky and believe the worst is behind them. It is not the water in the air that gets them. It is the water already in the ground. Picture the slope above Baguio at the exact moment the rain stops. On the surface, everything looks calmer. The sky is lightening. The wind is gone. But underground, in the meters of soil clinging to that mountainside, an invisible process is only now reaching its most dangerous hour. And it is a process almost nobody watching the sky can see. And here is why the timing is so lethal.
Water does not soak down through a slope instantly. It takes hours, sometimes many hours, to percolate from the surface down to the depth where a slope actually fails, along a plain deep beneath the grass and the trees. So the water pressure at that critical depth keeps climbing even after the rain at the surface has stopped. The rain ends, the pressure keeps rising. The grip keeps weakening. And then, on a clear morning that feels safe, the friction holding the slope finally loses to the weight of the saturated soil above it, and the whole face lets go at once. That is the cruel arithmetic of the landslide. The most dangerous hour is not the hour of heaviest rain. It is the hour after, when people have relaxed, when the roads have reopened, when someone walks back up to check on a house. The mountain does not fail on the storm's schedule. It fails on the water's schedule, and the water runs late. The Cordillera is built for exactly this failure. Steep slopes, deep soils, communities and roads carved into the mountainsides, and 3 weeks of rain already stored in the ground before Maysak added its share. When a slope finally goes there, it does not slide gently. A saturated mountainside can come down as a debris flow, a churning slurry of mud, rock, and shattered trees, moving with the speed and force of a fast river, capable of burying a house or a stretch of road in seconds. And it gives almost no warning. One moment the slope is there, the next it is in the valley. That is the quiet killer of a storm like Maysak. Not the wind that already faded, not even the flood you can see rising in the street. It is the slope you cannot see, doing its work in silence, on a schedule that runs behind the storm. So the danger is real, and it is still unfolding. But I want to be honest with you now about the edges of what we know, because uncertainty is a part of this story, and pretending otherwise would be its own kind of dishonesty. The rain totals from a storm like this are genuinely hard to pin down in advance, and here is why. The exact amount of water that falls on any single valley depends on where the storm's rain bands set up, how slowly it crawls, and how tightly it locks onto that monsoon flow. And small differences in the track produce large differences in the rain. Shift the storm's center by a modest distance one way, and a particular mountain range gets pounded. Shift it the other way, and it gets a fraction of that. This is why the forecast track through southern China stays a little smeared on the maps, even after landfall. It is not that the forecasters are guessing wildly. It is that a slow, weakening, rain-driven system is inherently harder to nail down than a tight, powerful one. Its future is written in soft ground and shifting bands, not in a sharp eye you can point a satellite at. When forecasters cannot pin the exact ceiling, the responsible move is not to relax. It is the opposite. It is to prepare for the high end of what is credible, which is exactly why a city of 9 million people threw its top-level alarm at a storm whose winds had already collapsed. That uncertainty is not comforting. It is the reason for the alarm. And whenever a storm does this kind of damage, the theories arrive right behind it. That the storm was steered, that it was seeded, engineered, aimed on purpose, that the true scale of the flooding is being hidden by the authorities. These questions deserve a straight answer, not a smirk. So let me give you one, and let me answer it the way the physics does. Start with the energy. A mature tropical cyclone is a heat engine of almost unimaginable scale. The amount of heat energy it releases as it condenses water and drives its winds runs, by conservative estimates, into the hundreds of times the entire electricity output of the whole human race, every single hour it exists. Hold that in your mind. Every hour, hundreds of times everything every power plant on Earth generates. There is no installation, no antenna array, no facility anywhere on this planet that produces a fraction of that. You cannot steer what you cannot power, and no human system comes within a rounding error of powering a storm the size of a piece of ocean. Weather at this scale is not a machine anyone built. It is the atmosphere doing what warm water and rising air have always made it do. And the "they're hiding it" theory falls apart on contact with the actual behavior of the agencies. Think about what you have watched happen in this story. The Chinese authorities published their reservoir breach. They announced their top-level response.
They ordered evacuations in the open, suspended transport in the open, posted their rainstorm and flood warnings in the open, for the whole world to read. That is not the behavior of a system trying to hide the scale of a disaster. That is the behavior of a system shouting about it as loudly as it can, because shouting is what saves lives. The alarm is the opposite of a cover-up. A cover-up goes quiet. This went loud. The truth is both less sinister and more sobering. No one had to build this storm, or aim it. Warm ocean, a wet monsoon, and a slow-moving system landing on saturated ground were more than enough. Nature did not need any help to do this, and it did not get any. So let me leave you with the things worth watching over the next 72 hours, because you now understand this storm well enough to read it yourself and to know which signals actually matter. Watch the rivers, not the rain. The rain in the mountains is only the first act.
The real number to follow is the river level downstream, on the plains of central Luzon, along the rivers draining into the low districts of Manila and across the flooded south of China. Rivers crest hours to days after the rain that filled them, so a river still rising under a clear sky is telling you the water from the mountains is still on its way down. That rise is the storm's true signature, arriving late. Watch the reservoirs. In the Philippines, follow whether the big dams above Luzon are still making controlled releases, because every release is more water added to rivers that are already full. And in southern China, after one reservoir has already breached, the question is whether the others hold. A dam holding is a quiet victory you will never hear about. A dam failing is the fastest way this gets far worse, and it happens with almost no warning. Watch the slopes, especially on the clear mornings. The landslide risk in the Cordillera and above Baguio does not fall when the rain stops. It peaks in the hours and days after, as that water finishes soaking down to the depth where slopes fail. The most dangerous moment is precisely the one that feels the safest. And watch the human numbers as they firm up. The counts of dead, missing, and displaced from an event like this almost always climb in the days afterward, as rescuers reach cut-off communities and as the rivers finish their work. The early figures are never the final ones. They are the floor. Now come back with me to where this all began. On the 4th of July, this was a wobble of thunderstorms in the Pacific, so faint a satellite could barely draw a circle around it, the kind of thing that should have amounted to nothing. Within a day, it had a name, and it became the 5th named storm to strike the same drenched country in 3 weeks, then crossed the sea to become the first tropical cyclone to reach the Chinese mainland in 2026. It never became a monster on the wind charts. It did not have to. It arrived at the exact moment the ground could not take one more drop, and it turned water into the weapon. So here are both halves of the truth, because you deserve both. The half that is already certain. Real people in the northern Philippines, on Hainan, across the flooded south of China and the border towns of Vietnam have already lost homes, roads, and lives to this storm. And the water still moving through the rivers and the slopes means that toll is not finished. It will grow before it settles. and the half that is honestly uncertain. Exactly how bad the flooding downstream becomes still depends on things we cannot fully measure in advance. How much rain fell on which valley, whether the reservoirs hold, which slope lets go, and which one holds on. What we can say for certain is that the danger did not leave when the wind did. It went underground, into the rivers and the hillsides, and it is still working. That is the lesson a storm like Maysak writes over and over, in a language of clear skies and rising water.
The frightening part of these events is so often the quiet part, the part that comes after, when everyone thinks it is over. If this is the way you want to understand these storms, not as headlines that flash and vanish, but as physical events you can actually read while they unfold, then subscribe and stay with this channel. We track them in real time, with the real numbers, from the first faint wobble on a satellite to the last river cresting under a clear sky. Because by the time the headlines catch up, the water is already moving. And now you know exactly where to look.